Those are yawn. Good morning, boys. Today's lesson 2. Oh, you can't even see my hand. 2.7 Solving Literal Equations. Now, I don't know why the heck it's called a literal equation. And I've never heard of a literal equation before. But that's the name in the lesson. So we're going to go with it. Now, this lesson, you're going to see some new things. And you're going to feel confused by it. And I need you to know right now, don't work yourself up, don't overthink it, because I know you know how to work with these based on everything we've done so far. Now, this is the key. We're looking at two variables in this lesson in the same algebra equation. The thing to keep your mind straight and to not overthink it, only think about the variable we're interested in. If you do that, you can solve these the exact same way as you've been solving everything else. So it's very important that you don't overthink it. You find the variable we're concerned about, and you solve the equation that way. Let's start with a refresher of some definitions. Well, before we do that, so let's read this sentence. Let's take a look at some equations here. So this first one here, this is an equation that tells us how many minutes we have if we have a certain amount of hours. So if we read this in English, well, first let's think about it normally. If we have 1 hour, how do we get the number of minutes? Well, we know there's 60. If we have 2 hours, how many minutes do we have? We have 120. What are we doing there? We're multiplying by 60 each time. So this equation right here says the number of minutes equals the number of hours times 60. So we know that logically, this is just how it's expressed algebraically. Now in this equation, m is by ourselves, the number of minutes. So this equation tells us how many minutes we have if we know the number of hours, right? So if we have 1 hour, we plug it in here, we get 60 minutes. If we have 2, we plug it in here, we get 120. So the number of minutes is dependent on the number of hours. Dependent variables are the ones that are usually by themselves, dependent, because they depend on the other variable that we're plugging in, dependent. Now the other variable, the one that we're substituting and changing, we call that the independent, because we get to control that one, independent. So if we change hours to 1, our minutes is going to change. The minutes depends on the number of hours. If we change our hours to 2, the minutes is going to change to 120 because the minutes depends on the hours. In this case, in this equation, because m is by itself. Now, let's take a look over here. Remember, distance equals rate times time. So if we're going 3 miles per hour in 2 hours, how many miles have we traveled? 3 times 2 gives us 6 miles. That's what this equation does for us. So notice we get to control the rate and the time. We get to change those values. But the distance is dependent on the rate and the time. So in this case, distance is our dependent variable. Rate and time are our independent, because our distance depends on our rate and our time, and we can also tell because it is by itself. So whenever a variable is by itself, it is almost always our dependent variable. Oh shoot, ow. Just realized I was recording when I meant to be paused. So you're welcome. Unfortunately, I'm not at the point yet where I can edit these videos, so you're just stuck with it. So, Anywho, okay, so let's say So if we're given a number of hours, if we are given the number of hours, then we can figure out the number of minutes. And the way it's set up here, we got an if-then statement. But let's say instead, what if we're given the number of minutes first? Do you know how to get the number of hours? What if I told you we had 180 minutes? How could you figure out the hours? Well, you can just divide by 60. 180 minutes gives you 3 hours. So we want to write an equation that tells us how many hours we have given the number of minutes. We want the number of hours to depend on the number of minutes. So what did we learn about dependent variables? Dependent variables are by themselves. If we have the number of minutes, then we get the hours. We want hours to depend on minutes. We want hours by itself. Luckily, we have strategies to get variables by itself. And that's what we've been doing in all these lessons so far. So let's take a look at this equation here. Now, I know there's two variables, we're not used to that, but only think about what we care about. Only think about the dependent variable. What do we want to get by itself? We want the hours by itself. So let's look at the hours. So what's happened? We want to get hours by itself. What's happening to hours right now? It's being multiplied by 60. How do we undo multiplication by 60? We divide by 60. What we do to one side, we do to the other. These things cancel, we're left with h on the right side, and nothing can simplify on the left, so we're left with m divided by 60. There we go. So what does this say? Let's read it in English. And whenever we read in English, we usually want to start with the dependent variable. The number of hours is equal to the number of minutes divided by 60. There we go, just like that. So if we have 180 minutes, divide by 60, that gives us 3 hours. So what did we accomplish? We changed our dependent variable from minutes to hours. Ooh, very cool. And it's very important, even though there's two variables, don't let that confuse you. Think about the variable we care about and perform your algebra that way. Okay, we're on page 70, example 2.7b, in case you're interested. Now, let's take another equation. Hold on, I'm getting a phone call. As you can see, that phone call I just had was significant enough to make me change venues. So, we'll be proceeding from here. Can you still see my head? I guess you can. Alright, so let's take this new equation right here. And why is my board not working? Oh, shoot, sugar. Okay. Okay, let's take this equation. Now, you don't need to know what it represents in order to solve our equations, but I'll go ahead and tell you. This says perimeter equals 2 times the length of the rectangle plus 2 times the width of the rectangle. There you have it. But we don't. So let's see what the question says. Once again, we're on page 70, example 2.7b. It wants us to solve the equation for L. Solve the equation for L means make L the dependent variable, which means get L by itself. Okay, so let's get L by itself. So once again, even though there's 3 variables, don't let that confuse you. Zero in on the variable we care about. So what do we normally say when L's by itself? Well, we say, what's happening to L? L is being multiplied by 2 and added by 2w. So how do we undo addition by 2w? We subtract by 2w. The same exact step. It just seems a little weird because there's a variable, but you don't need to overthink it. We're doing the same exact process. What we do to one side, we'll do to the other. These things cancel. We're left with 2L on the right. P minus 2W, neither of those can combine, so we just rewrite it. P minus 2W equals 2L. Alright, we want to get L by itself. What's happening to L? It's being multiplied by 2. What's the opposite of multiplication by 2? Division by 2. What we do to one side, we'll do to the other. These things cancel. We're left with L on the left and on the right, and then on the left, there's nothing really we can simplify, so we can just rewrite what we have, 2W. So there we go. We got L by itself. L is now the dependent variable. We have solved for L. Now, you're like, oh, but it doesn't equal an exact thing. It doesn't have to equal an exact thing. We just need to get it by itself, because now on the left, if we want to know the length of our rectangle, we can plug in the perimeter, and we can plug in our width over here and calculate whatever, and it'll give us the length. This is just a tool to find an unknown quantity if we have the other two quantities. After consideration, that's all I'll do for this lesson. Just keep in mind, dependent variable is usually the one by itself. We plug in the other variables, and as a result, we get the dependent variable. If we want to solve for a variable, that means get that variable by itself. And when we are doing the processes, don't worry about all the other variables. Just focus, because that'll confuse you. Just focus on the one we're concerned about and take our normal algebra steps and processes to get there. Other than that, I'll give you plenty more examples in the example video, and I'll see you there. Bye!